Hey, welcome to lesson 4. We're going to hop right into it. We're on page 527. We got some review problems at the bottom. Today we're learning basically how to simplify radicals, add, subtract, multiply, divide them. The whole radical thing. So let's go to the review on page 527. It's at the bottom. We're going to review how to simplify some of these square roots. And the way that I've always taught it is I put my perfect square number line. 1 times 1, 2 times 2, 3 times 3, 4 times 4. You know how that works. And when I'm simplifying a square root, I look at that number line and I find the largest perfect square that will multiply to, in this case, will be 48. So the largest one is going to be 16. 48 actually equals 16 times 3. And when I do that, I can take the square root of 16 and I get 4 radical 3. Easy enough. Let's try the next one. 27. I look at my perfect squares. Hey, that's 9. All right, 9 times 3. Make sure my little tail is on there. Square root of 9 is 3, so this one ends up being 3 radical 3. I've seen teachers teach this different ways, and they build these huge ugly trees and all that. But the best way, I'm telling you, is to look at the number line, find the largest perfect square that multiplies to whatever's under the radical, and then you can just simplify it. Like this one will be 4 radical 2. Let me show you what can happen if you're just picking random numbers. Like most kids would pick 4 and 8 with this one, and they would get 2 radical 8. But guess what? That's not simplified because that breaks down into 4 and 2 again. And now we have this big tree thing going. Oh my goodness. And then this, and then kids get confused. Nah, that's ugly. We don't want to do that. So that is a review on radicals. Fantastic. I'm going to review some of our rules of exponents as well. You should know these exponent rules by now. So if you have a common base and you're multiplying two terms, you can add the exponents. But if you're raising powers to powers, you multiply the exponents. If you divide, it's the opposite of multiplying. So instead of adding, you subtract. Anything to the 0 power is 1. We know that. A negative exponent means 1 over the positive version of that. So if this is a negative 2, that's the same as 1 over a squared in that case. And the same thing, if you have a negative in the bottom, you can pull it up top as long as you change the sign. Notice that neither one of these are negative, right? It just means that it goes in the bottom of the fraction. That's a common mistake that students make. So those are all the properties of powers that we need for this lesson today. So we're going to go through on page 528. Please stay with it today because there's a lot of stuff. We're going to be flying through stuff. We're going to start on page 528. They want you to simplify some of these and get one of these solutions that's in the box there. I put our rules right here for you. Maybe you want to write them down to help you out. But, if you have two terms and you're multiplying and the bases are similar, then you can just add the exponents. So that would be a to the fourth. If you're dividing, you just subtract. So this would equal a to the negative 4. Down here, what do we get? You add them, right? So this equals a to the 0, but anything 0 power equals 1. If you have powers to powers, you have to treat each, whatever's inside each term needs to be treated identically. That 2's got to go to both of them. So this would equal a squared b to the 4th. We are flying. E would equal what? That's just a to the 4th. Easy. And anything over itself is equal to 1. That's easy. That 1/2 has got to go to both. So it's going to be a to the 4th b squared. And lastly, you have to add these two together, right? Because it's side by side. So you get a to the negative 4th. I do believe all of these are one of the solutions that's in that box. So we are good to go there. Let's go to page 533. Told you we're flying. 533 talks about how you can write a square root as basically a power of 1/2. So here's a little proof for you. You can rewrite an expression in radical form. Solve the equation. The square root of x equals x to what power? X to the a power. And then we'll solve it for a, given that x is greater than or equal to 0. So here's how they do it. They basically say square root of x equals x to the a. We'll square both sides. So that'll give us 2a equals, and then if you square a square root, they cancel, right? So they go away. And now we're left with the equation x equals x to the 2a. Well, this is the first power. So now that that's to the first power, we can set the exponents equal. We can solve it, and we get a equals 1/2. So from this, we know that the square root of x equals x to the 1/2 power. That's one of the rules that we will use. Hey, look at that. Given that x is greater than 0. What? Why does the beginning worked example state that the restriction x has to be greater than or equal to 0? Well, let's think about it. What happens if we have in here a negative? That's one of our two rules we can't break in math. You can't take square roots of negatives. So the worked example states the restriction given x is greater than or equal to 0 at the beginning to ensure a real number value for x. We don't want imaginary numbers, right? We dealt with that earlier in the year. For x values less than 0, the value is imaginary, not real. And then how do you know when the initial x value can be any real number and when you need to restrict it? Well, a lot of that depends on you place restrictions when the x values when they're undefined in the original expression. So you always go back to the original expression. Let's give you an example of one of those. Page 534. I actually lied. We'll give you an example of that here coming up. Not yet, though. We're going to rewrite each expression in radical form. So how would you write the cube root of x? So cube root of x. How do I write that? With a rational, which means a fraction. So a fractional exponent. An exponent that's a fraction. So if you remember, the cube root of x is just x to the 1/3 power. Just like the square root of x is x to the 1/2 power. How about the cube root of x squared? So I would write that like this. Okay. And what I tell students is roots, like the roots grow underground. So the roots are in the bottom. The roots are in the bottom. That doesn't really go there. We're not going to raise the roots either. Boom. Raise the roots. Don't raise the roots. The roots are in the bottom. This would equal, the way that we can write it is x squared over 3, because that's the root. So it's x to the 2/3 power. So now let's practice this skill a little bit. We got a little table here. You guys like some tables? So as I said, the roots are always in the bottom. So if I were going to rewrite the 4th root of x squared, I would write the roots are in the bottom, just like, onions. And then the restrictions. Okay, so this is a 4th root, so it's even, right? So you can't have a negative number underneath. Just like a square root can't be negative underneath. No number times itself squared can give you a negative, right? So no number times itself 4 times. That's what the 4th root means. What times itself 4 times would give you a negative? You can't have that. So the restrictions here is that x has to be greater than or equal to 0. Let's look at the next one. We're going to work backwards with it, but this would be the 4th root of x cubed, right? And so that means we would have, the 4th root of x cubed in the bottom. But it's a 4th root again, and this is a cube, so that could be negative. So we need to say that x needs to be greater than or equal to 0 on that one. Well, let's look at the next one. I bet you can feel something's gonna change. A little something's gonna change. This is the 5th root of x squared. So they want you to write it like this, which over here means we would have the 5th root of x squared. But can odd roots be negative? Like, can you have, I'll just do an odd root over here. Is this permissible? Well, look, this all equals -2. What's -2 times -2 times -2? It's a negative. So odd roots can be negative. How about that? So what are my restrictions? I don't have any. So I'm just going to write that fancy R there. Remember that fancy R means all real numbers. Or you could use words too. All real numbers. I don't need to say x has to be greater than or equal to 0 because it's an odd root. So I don't need to worry about that at any time when I have an odd root. Let's do 1/5 here. What would that be? That would be the 5th root of x to the 1st power. And what would that all be? That'd just be the 5th root of x. Let's just write it like that. And once again, all real numbers. Just draw 2 lines and an R, and that means we have all real numbers. Woo! We are flying. Now we're on page 535. There are 2 ways we're going to look at to extract roots. Or, most students think this is simplifying square roots. We're going to simplify this into its most simple form, and it's extracting all the roots. You want to get all the roots out of it. And there's basically 2 ways to do it. Here's the first way, using radicals. So if we have the 3rd root of 8x to the 6th, what I can do is I can rewrite that 8 as 2 to the 3rd power. Now I'm going to say this. It sounds like double talk, but the cube root is, what is the term that when you multiply it by itself 3 times will give you whatever's under the radical? So what multiplied by itself 3 times will give you 2 to the 3rd? It's like the double talk. What times itself 3 times will give you 2 to the 3rd? And the answer is 2. 2 multiplied by itself 3 times will give you 2 to the 3rd. Okay, so how does that work for x to the 6th? If we can write it to a 3rd power, then we can just pull out whatever has been written to the third power, as long as it's a third root. The same thing works for square roots if you can write to the squared power, but we'll get to that here in a second. So short version of this is the third root of 2 to the third is 2, and the third root of x to the 6 is x squared, and that comes out right here. Now, the way that I like sometimes is I think of these roots as fractional exponents. So this means raised to the 1/3 power. That's a little tricky though, but you get 2 raised to the it's 2 to the 3rd power, right? And then you raise that to the 1/3 power. That 1/3's got to go to both. So when you multiply that, you get 2 to the 1st and you get x squared. Sometimes that's a little bit easier there, but we'll use both methods right here. Which method do you prefer? They give you no space to write. So we're going to look at Embry's and Devon's. Let's look at Embry's method right here. We have a 4th root of j to the 8th. So remember that you can rewrite that as j squared to the 4th. That'll come out as j squared. Nice. Now, what about over here? We have the 4th root of k to the 4th, which equals just a k. They put absolute values around it. What is up with that? We're going to come back to that here in a second. Let's look at Devon's. So Devon has what here? Devon just went the way I like to. Just start at the beginning, raise it to the 1/4 power, and that 1/4 can go on each one of these terms. You multiply it. Once again, we have an absolute value here for k. So number 2 says, why is it necessary to use an absolute value? Do you remember what absolute value means? Absolute value means you got to make sure it's positive. It's always positive, no negatives. And that goes back to what we talked about before. You can't have square roots of negatives. You can't have 4th roots of negatives, because no term times itself 4 times can ever be negative. No real term, right? That would give us imaginaries. So it's not necessary to use the absolute value for j squared because you're squaring j. That'll always be positive. J squared will always be positive. So that means, you know, when we plug this in the original expression here, it'll always be positive. I don't have to worry about it. However, k might be negative. And if k is negative, there's no way I can take the 4th root of something and end up with a negative. That doesn't work. So we're only talking about positive values of k here. It is necessary to use the absolute value of k for the answer in order to communicate the principal root. The principal root. This sounds serious. Principal. Go see the principal root. Principal root means the positive root, which is non-negative. Okay, we're now on page 536. We are flying here, so don't be afraid to pause the video if I'm going too fast for you. Or you can slow me down using YouTube's settings there. I'm going to speak a little slower to you. So anyways, 536. What do we got? Letter A here. We have the square root of m to the 4th, n to the 6th, which I would write, you know what I love? I love these fractions here. Let's just raise that to the 1/2 power, right? Because that's what the square root means. So this would all equal m squared, but n to the 3rd. Now, here's the thing. Is this a square root or an even root? Yes, it is. So can it ever be negative on the inside? No. Will m ever be negative? No, because you're squaring it. Will n? Well, it could be. All right, so we're going to put absolute values around that n cubed. All right, done with that one. Easy enough. Let's look at B. We're going to raise this to the 1/3 power, so we're going to get j to the 12th over k to the 3rd. And we're raising this to the 1/3 power, right? Okay, so what does all that equal? That means you can multiply these exponents. We're going to get j to the 4th over just regular old k, right? K to the 1st. This is a 3rd root. Can 3rd roots be negative? Yes, they can. I don't need to worry about absolute values in this one. We're done with B. I'm going to keep going and do a couple more of these 7, and you're going to finish up these 7. Number 7 here. All right, I'm going to look at A. This is pretty easy. We're going to rewrite the radical by extracting all the possible roots. So this is equal to the square root of 16 times the square root of x to the 6th. Now, using the fractional exponent here, this is 1/2, right? So x to the 6th to the 1/2, that's just going to be x to the 3rd. Look at the little rule. You just divide it by 2 when it's the square root. Square root of 16, though, don't divide that by 2. That's equal to 4. So this expression right here is 4x to the 3rd. Easy enough. Now, we have a positive. We have a even. This is an even root here. And then will x ever be negative? It could be, but we can't plug negatives in there. So I'm going to add my absolute value bars. Whoa. How fun is that? Let's go to B. B has a negative in front, and then we have the square root of 8, and then we have v cubed. Well, I'm going to rewrite the square root of 8. You know what that is equal to? Let's just write that as the square root of 4 times the square root of 2. And the reason I'm doing that is because the 4 will simplify. Haha. I'm going to do the same thing with a v. So I can write this as v squared and an extra v there. So I have a negative sign. That's just chilling. Then I have the square root of 4. That's a 2. I have a square root of 2. And then the square root of v squared. That's going to give me a v, right? Because that's raised to the 1/2 power. They cancel. And then this one's just kind of lonely. Doesn't simplify. So if I put all of the non-radical things out front and then all the radical things can go together, that will be our final answer there. What do we have to worry about in terms of absolute values here? Because we have a v out here and this is to the 3rd power, can that ever be negative? Well, if v is negative, we're going to run into issues. So guess what I'm going to do? Throw a little absolute value around that. Now, do I need to throw an absolute value around the 2? Because I pulled the 2 out as well. Well, 2 is always equal to 2. It's never going to be negative unless we throw that negative sign. Then we know it's negative, so we don't have to worry about it. All right, let's go down. Let's do E right now. E looks pretty good. So we have the square root of 25. I'm going to break this up a little bit. Square root of 25. And then we have the square root of a squared. And then we have the square root of b to the 8th. And then the square root of c to the 10th. Well, square root of 25 is 5. Square root of a squared, it's like to the 1/2 power, so they kind of cancel, right? We know they're opposites, so that'll be a. The square root of b to the 8th, that's going to give me b to the 4th. And then the square root of c to the 10th is c to the 5th. Well, here's the deal. I'm going to go back and ask the same question. This is a square root. So when we get our answers, are any of these potentially negative? The b is not going to be negative because it's b to the 4th. The 5 is not going to be negative because it's 5, right? So we can put the 5 and the b to the 4th together. But the a, we can put absolute values around. The same thing with c. We can put absolute values around that. Or they can be in one giant absolute value. That doesn't matter because they'll always be the same here. So I'm just going to write it that way. B to the 4th, absolute value of a, c to the 5th. And again, why are we doing the absolute value? Well, the absolute value is because you can't have a negative square root. That's one of those rules you can't break in math. All right, I'm going to do F, and I'm going to have you finish the rest, okay? So F, 4th root of 81. Let's just break that up. We'll leave it right here, 4th root 81. Now, this is a 4th root, not a square root. So I'm going to break up the x into 4 and then 1 left over. So if I take the 4th root of x to the 4th and the 4th root of x to the 1st, and if I multiply those, it gives me x to the 5th. The reason I'm going to break it up is because I'll simplify that first one. That looks real good. And then I have the 4th root of y to the 12th. So how does this all work out? The 4th root of 81. What times itself? 3 times. Sorry, 4 times. We'll give you 81. I was thinking 3. You know why? 3 times 3 is 9. Times 3 times 3. Another 9. 81. So this equals 3. The 4th root of x to the 4th, that's just an x. Right? So I can raise that up as a 1/4 power. They will cancel out. I get x. This one's got to stay. I'm going to write that, but I'm going to leave a little space because I know we have the 4th root of y to the 12th. So that's 1/4. That'll give me y to the 3rd. And then this guy's got to stay inside, right? All right, so that's what I get. Now I need to think about that. Do I need to worry about any restrictions here? This is a 4th root. It can't be negative on the inside. Are any of these terms going to be negative? Well, the x could be negative, and the y cubed could be negative if y is negative. So I'm going to write this as 3. I'll do absolute values. X, y cubed, other absolute value, and then I have the 4th root. Oh, that's an ugly 4 of x. And that is F. Oh my goodness. Finish all of these through H. Any that we skipped, go back and do that, and then we'll check it right now. Ready, so go. Pause the video and try it yourself. All right, so let's check it out. I have in blue here the ones that you should have done. So hopefully you did all right with them. So I pull it out, you get d squared and d. That one d's got to stay inside. D squared turns into a d, but absolute value. Those are absolute value signs right there. So the absolute value d, the f to the 4th becomes an f squared. Final answer, absolute value df squared times square root of d. Now, part D here, what do we got? Square root of h to the 4th, that's h squared. The square root of j to the 6th is j to the 3rd. This is a square root. Could anything ever be negative? Yeah, the 3rd power thing could put absolute values around it. H squared absolute value of j to the 3rd. Let's go down here. G is easy, right? You raise it to the 3rd power. It's a 3rd power. I don't have to worry about absolute values. Boom. 9 times 1/3 is 3, and you're done. This is a square root, though. I saved this one for you. Square root. So the square root will cancel the square, but guess what? This is x plus 3. You got to put those absolute values around it because that's a square root, and this thing can never be negative. So we put absolute value signs around it. That was fun. Let's crank it up another notch. Let's go to page 539. We're going to look at 4. We're going to jump right into it. And the good thing is your book, they usually go ahead and they pre-restrict you so that you don't have to worry about that in this situation. They're telling you that x has got to be greater than or equal to 0. So they just want you to perform each operation, which means in this situation we're going to be multiplying. Now, things that we need to know. Whole numbers and whole numbers, they play nicely. So 2 times 5 is 10. And then a square root times itself, right? Square root times itself, they cancel. So these two right here would just give me a regular old x. The other way you can think about it is x times x is x squared, and you get the square root of x squared, and then it cancels. However you need to put it in your brain. But we do have an extra square root of x, so that's got to chill. And they already told us things have to be positive, so we're all done with that one. Boom, easy peasy. How about b? We have a 2, and then we have a cube root of k, but we have 2 k's, so I'm going to say k squared. That's it. That's the best we can do. We can't simplify that any because you only have 2 k's. 2k, but it's a cube root. I would need 3 to simplify it. So that one is good. How about C here? Oh, I need more room. Okay, here we go. We got more room now. I'm going to distribute just like I would normally. All right, how's this all going to work? We have, it's like the distributive property when we have variables. It's 7 times 3, that's 21. And then the square root of h times the square root of h. That's just h. So that's my first term. Then I put plus. Now it's 7 times 4, which will give me 28. And then the square root of h times the square root of h cubed. I'm just going to write that right now as h to the 4th, right? Because you have h times h cubed is h to the 4th. But now I can simplify this. So my final answer is going to be 21h plus 28h squared. And again, I don't need to worry about restrictions because they pre-restricted. And how about D right here? We have a square root and a cube root. Oh man, so to help me sometimes I'm like, I'll just go into the fractions here. This is a to the half, right? And then this is a to the 1/3. So what is my rule when I have two terms, the bases are the same, and what do we do with the exponents here? The rule is you add them. So I want to show you how to do that in your calculator because you know what? No offense, but y'all in fractions. So my recommendation is always use parentheses when you're putting these fractions in your calculator. This is 1/2 plus 1/3. This is how I would do that. And I would just put it and I said enter. Oh, that is a decimal. Do not use decimals here. We're going to change that into a fraction. Did you know you could do that? You can slow that video down, but it's 5/6. So this would equal a to the 5/6 power. I'm going to rewrite that as a root. Remember the root goes out front. It's in the bottom. So this is the 6th root of a to the 5th. We'll just write it like that. That's good enough. Okay, let's look at E and F on page 540. What do we have here? This is ugly. All right, let's put it all together here and see what we got there. You can multiply. These are called like terms because you got the same radical right here. So I'm just going to put that n out front, and then we have a cube root of, now I can multiply this all together. So 4 times 4 is 16. Then we have n to the 3rd. So how would this work out? By the way, always make sure your 3 looks like, I'm doing a terrible job here. That should be like little tiny index. There you go. Boom, got it. So I'm going to break that 16 up. So that is the cube root of 8 and the cube root of 2. And then we have the cube root of n to the 3rd. And that other regular old n is just hanging out there. So the cube root of 8 is a 2. So that equals 2. We have an n. We have a 2. This has got to stay. So cube root of 2 does not simplify anymore. But that all equals a regular n. So your final answer for this would be a 2. We have 2n, so that's an n squared, and a cube root of 2. Whew! That is E. How about F? F, you know what I'm going to do? These cancel, right? What's the rule when you divide? You have a like base, and you divide. You can subtract exponents. 2 of those will cancel 2 of those. And I basically get the square root of 4x squared. I can take the square root of 4. I can take the square root of x squared. This all equals 2x. And guess what? The restriction's already there. but the restriction is for dividing. The restriction is not for taking square roots here, which can never be negative. I better add my absolute value to that one so that I never get a negative number inside that square root. That is page 540. That is multiplying basically radicals. That's what that is about. We're going to go to 541. You can read through this, but essentially the rule is going to be this. If you want to add and subtract to find the sum and difference of radicals, they have to be the same exact thing. Just like you can add x's to x's, you can't add x's to x squareds, right? So that radical's got to be the same thing, and then you can just add the coefficients in front. So 3 square root of x plus 1 square root of x would be 4 square root of x. Easy enough. So let's move forward to 542 now. 542, combine like terms, if possible, and write your final answer in radical form, no exponents. So congratulations, you made it to the dumbest question in the entire book. Square root of y minus the square root of y. That's 0. All right. Why would they ask you that? Anyways, what a waste of ink that was. Part B, we have 9 square root of a plus 5 square root of b. Guess what? You can't, these are different. These have to be the same in order to add them or subtract them. So that is not possible. They are not like terms. Ugh. How about C? Well, we have a square root of x. Nice. Another square root of x and another square root of x. This looks pretty good. They're all the square root of x. This is like a 1 there, remember? So it's like 2x plus 1x plus 5x. What would that give us? Well, same thing right here. We'd get 8 square root of x's. And x is already greater than or equal to 0, so I'm done with that one. And now it's your turn. Why don't you do D, E, and F right now? So pause the video and do D, E, and F all by yourself. Ready, set, go. Okay, here's what I got. You can just put the coefficients together, get 5.3 square root of h. Can't do anything else there. Don't have to worry about restrictions. They already did that. Nice. So E, distribute, you get 3t squared, but that'll simplify to t. 24t squared once again, and 4t, not 40, but 4t, and then you put the coefficients together, negative 17t, and then f. You can't do that. It's not possible. Wow, this was a long lesson. There's a lot of stuff in there, so make sure you check your answers. What do you have to do for homework? Hey, look, I put a little screen right here. You can pause it and write it down. How about that? Way to go, Mr. Kelly. It's Mr. Kelly in K-Town. Remember, it's nice to be important, more important to be nice.